Welcome to my channel, Code with Fernando. Let's continue with object reference variables. First, we need to understand what is an object. An object is an instance of a class that represents real-world entities. How object reference works in Java? In Java, variables or reference types does not store the actual object. Instead, they store the memory address, a reference, a pointer, just that, a memory address. For example, let's create a class called person. Okay, class called person. We are declaring the reference variable, but not creating the object in here. Here, person is a reference variable. This person is a reference variable that can point to a person object. However, no object has been created yet because we are not using the new operator yet. So the reference holds a null value. Reference object by default they're going to be null. When an object is instantiated using the new operator, three things happen: memory allocation, reference variable, and memory address assignment. Okay, memory allocation. A new person object is created in heap memory. In heap memory, remember that we have two types of memory in Java: stack memory and heap memory. So whenever we use the new operator, that new object is created in heap memory. Okay, reference variable. A variable person. Remember this person. Okay, this person. The reference is created in stack memory. In stack memory, initialize it holds new. Okay, memory address assignment. Then the reference variable person is assigned the memory address to the newly created object. So this person will store the memory address of the object that we just created. So new person creates an object in his memory. For example, let's say this B1050 is stored in person stack memory. So this pointer, this reference variable, will hold this reference. Okay, some key takeaway. The new operator dynamically allocates memory from object and returns its reference. Okay, so this new operator will dynamically allocate the memory. Okay, let's understand uh, what is stack memory and heap memory. Stack memory is all about method execution context. So stack memory stores a reference variable, okay, and memory is automatically managed and free when a method ends. On the other hand, we have heap memory. Heap memory is object storage. It stores actual objects created with new. Memory is managed by the garbage collector. Okay, so we have here a little example. Whenever we use the new operator, it's created in heap memory. Okay, so let's pretend that we have this number as a reference. Okay, and in stack memory we have the reference variable. Okay, that reference variable holds this address. That's why it gets B1050. Okay, let's understand what is the new operator because I have already talked about that, but let's see the new operator in action in detail. So the new operator in Java is used to create objects dynamically in memory. Okay, we know that already. It allocates memory in the heap and initializes the object using a constructor. Okay, the new operator returns a reference to the newly created object. So whenever we use new operator, this object reference, the object name, will get the reference of the new object created. For example, we have person. This is creating an object of type person. This is the reference variable. This is the new operator. This is calling the constructor. Okay, the class, the blueprint of an object. We know that the person, this one is a reference variable. It stores the memory address. New, we are creating the object, and we are calling the constructor in here. So every object creating using new gets a unique memory address. Okay, every object using new gets a unique memory address. This is a very common interview question, by the way. Okay, let's continue with our example. So we know that we have two memories in Java, right? We have stack memory, and we have heap memory. Okay, let's see something interesting. So let's create a person. So right now we're creating an object of type person, but but it's not initializing yet. So in here we have person stack memory. Okay, person is here, but it holds null right now because we are not using the new operator. Okay, so what happens when we create the object like this? We are using the new operator. So whenever we use the new operator, the, the GBN allocates memory dynamically. So in here we have person A gets a memory allocation. Okay, so let's pretend that we have B1050. Okay, so now this reference variable, this reference is pointing to this place, is pointing to this person. So this reference variable will hold this reference. This is just the address memory. And let's continue with object reference variable versus primitive variables. Okay, what are primitive variables? Primitive variables store actual values directly in memory. Okay, we know that Java has 8 primitive data types. These are byte, short, int, long, float, double, char, and boolean. Okay, these all values are stored in stack memory, making them fast and efficient. On the other hand, we have reference variables. Object reference variables store memory addresses. This just they act like a pointer. Okay, objects are created using the new keyword and live in heap memory. The reference variable acts as a pointer to the object in the heap. Okay, for example, let's create a primitive variable using int. We are calling it a, and we are assigning it 77. Okay, this will get stored in heap in stack memory. So like this, like this. Let's call it a, and we know that the value is 77. Okay, this is not stored in heap memory. This is stored in stack memory. So primitive variables, they're stored in stack memory. Okay, when a primitive variable is created, like this one, okay, what happens? The actual value is stored directly in the stack. Stack memory is fast and automatically managed. We have object reference variable that are stored in the stack and heap memory, in both. Okay, we know that when an object is created, what happens? Using person, using the new operator, we are calling the constructor in here. So the stack store the reference memory address. Okay, stack is store the reference, just the memory address. Okay, this is the stack memory, and this is just reference. This is holding the memory address. This memory address. Then we have heap. Heap stores the actual object. So we know this person. This is in heap memory. This is actually holding the person object. The reference variable points to the object location in heap memory. The reference variable points to the object. The reference variable is pointing to the object.